Hey, chemistry students, this is Mrs. Vanderwall. I'm sorry I cannot be with you today. I'm not feeling very well. So you got me in spirit and in voice, but not in person. So I'd like you to get your homework today. We're going to go over your homework, and then the sub will hand out the review for the test. We're going to talk about those 5 types of reactions we did last week. Opportunity to Learn is hopefully finished the review. If not done in class, well, please do it. Otherwise, we will hopefully have lab tomorrow. I'll be here. And if you owe me anything, please come and make it up. Obviously, today is not a good day, and I apologize if you're going to come in. So why don't you get your homework out, and we'll be right back. Okay, before we get started, let's review the 5 types of chemical reactions. The first 2 are very similar in the fact that you only have 3 things present. You have 2 reactants here and 1 product, and you have 1 product and 2 reactants. So they're very related. They're opposites. And when we had our actors and actresses out here, when 2 became 1, we called it a synthesis. Synthesis means to make. And then over here, somebody said something stupid. We won't ask who. And they broke up. They divorced. 1 becomes 2 products. And that divorce hopefully reminded you that this is a decomposition. We also have 3 others that are very similar because count 1, 2, 3, 4. Each of these have 4 species, 2 reactants and 2 products. So there's relationship with these as well. So what's the difference between 3A or 3 and B, 3 and 4? I'll get it. A is an element. It's by itself. It's not bonded with anything. It's a single dude is what we called it on Friday. And on 4 we have ionic and ionic. So we have a metal, nonmetal, metal, nonmetal, making a new set of metal, nonmetal, metal, nonmetal. So you have all ionic species here. Here you have an element in an ionic compound, and we call that a single replacement. That's when your single dude was replaced by B, or B was replaced by A, that kind of thing. So number 4, we have double swap. Everyone gets a new partner, so that's a double replacement. Finally, in number 5, here we have a very special form, and that's where you have 4 species, but 1 must be a hydrocarbon, the other one has to be an oxygen. So that's your reactants. Your products must be carbon dioxide and water. That is, of course, combustion. Okay, so as far as your homework goes, we had this worksheet right here, and unfortunately this worksheet did not include combustion. So we're only using synthesis, decomposition, single replacement, and double replacement, and I use those 4 things as an abbreviation. So the first part is just look, how many things do I have here? 1, 2, 3. I have 3 species, so it's either going to be a synthesis or a decomposition. So let's look a little closer. This is where 1 becomes 2. They're breaking up. And what did we call breaking up? That was decomposing. That was decomposition. Number 2, we have 1, 2, 3, 4 things, and so that's either going to be a synthesis, or excuse me, wrong one. It's either a single replacement or a double replacement. So let's look a little closer. This is ionic, and this is ionic. Wait a minute, Mrs. Vanderlei, how can hydrogen be ionic? Hydrogen's a nonmetal, but remember what we said about hydrogen. As an identity crisis, it's in the metal column, and it thinks it's a metal. So we treat hydrogen as a metal, nonmetal, metal, nonmetal. So what did we say? 4 things with 2 ionics is a double replacement. Number 3 also has 4 things. Ready? 1, 2 reactants, 1, 2 products. So we have to really ask ourselves, do we have 2 ionics like in number 2 or not? Well, we have the element magnesium right here. Magnesium is not bonded with anything. It's just an element. So we have an element and another ionic compound will give us single replacement. So we have a single swap. The magnesium and the hydrogens got new partners, or swapped out. Number 4, I'm seeing some O2 and H2O and stuff like this. Could this be combustion? The answer is no. I don't have 4 things. So I have to look at it again. I only have 3 things. So which is it going to be? This is where 2 becomes 1. And we said 2 becomes 1 is synthesis. Number 5, we're looking at 1, 2, 3, 4 species. So it's either going to be a single replacement or a double replacement. So let's look again. I just see aluminum here. Even though there's a 2 in front of it, it's still an element all by itself. An element can be a metal or it could be like a diatomic non-metal, but it's still by itself, just aluminum. I have 2 of them, but it's by itself. So I have 2 elements in a sense, and I have the ionic compounds. So element and a compound makes a single replacement. Number 4, I'm only counting 3 things. It's only going to be a synthesis or a decomposition. So Let's see here, I have 2 becomes 1. I'm making something, so that's, again, synthesis, just like number 4 was 2 became 1. Number 7, I count 1, 2, 3 things, and we said that there are 3 things, then it's either a synthesis or a decomposition. So I have 1 becoming 2, and that's a decomposition. Number 8, I'm counting 1, 2, 3, 4. So it's either a synthesis, or excuse me, it's either a single replacement or a double replacement. So I gotta look. Well, this is ionic, metal, nonmetal. So it's F2. It's an element. It is not an ionic compound, so it can't be a double replacement. It has to be a single replacement. Number 9, I have 1, 2, 3, 4 things. And I'm looking, this is definitely a metal, nonmetal. This is definitely a metal. These are 2 ionics, so it's going to be a double replacement. Number 10, I have 3 species, 1, 2, 3. I have 2 reactants and 1 product. So it's either going to be a synthesis or a decomposition. Well, 2 becomes 1, synthesis. Here I have 1, 2, 3 things. So it's going to be a synthesis or a decomposition. So let me look closely. I have 1 breaking up into 2 things. So that's going to be your decomposition. Number 12, look, ionic, 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 ionic. I have 4 ionic species. So the only thing that has 4 ionic species is a double replacement. Number 13, I have 4 things. So again, it's either single replacement or double replacement. So here's ionic. But wait a minute, what's this Br2? Is that an element or is it a compound? It's an element. It's a diatomic element. And so this is a reaction, and so it's not double, but a single replacement, because only the bromines and the iodines swapped. Number 14, I have 1, 2, 3 species. So it's either a synthesis or a decomposition. So if 2 becomes 1, it is definitely a synthesis. And finally, number 15, I'm looking at ionic, 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 ionic. 4 ionic things is a double replacement. So can you now turn your paper over and let's do the back. Okay, I did some of these balancing for you already. A couple of them I saved because they were a little bit more difficult, but I thought the easier ones I saved or I already did for you. I still have not discussed the types of reaction. Now notice the directions say there's 5 types, so combustion is also fair game. So let's just begin. Number 1, I balanced it, if you look. And I have ionic and ionic, ionic, ionic. So what did we say 4 kinds of ionic was? That's a double replacement, DR. All right, number 2, I balance it by putting a 2 here, and it seems to fix everything for you. And so now the question is, all right, what kind of reaction is it? I have 2 becoming 1. I only have 3 things. So if 2 became 1, that is a synthesis. Now, number 3, notice I didn't balance number 3 because it's not an easy one, and hopefully you're using a pencil because you're going to need that eraser. So I'm going to start off here. I have 5 carbons, 1 carbon. I'll put a 5 here. I have 9 hydrogens. I have 2 hydrogens. I'm going to put a 4.5 here. And now you're going to say, but Mrs. Vanderwell, you can't do that. And you're like, oh, you're right, I can't. So what are we going to do? Let's multiply everything by 2. We're going to put a 2 here. I'm going to save oxygen because I haven't balanced it yet. And then a 10 here. And then a 9 here. So I went ahead and took care of that 4.5. So let's see here. I have 10 carbons, 10 carbons. I have 18 hydrogens. I have 18 hydrogens. All right, let's do my oxygens now. So here I have 20 oxygens, 10 times 2. And here I have 9 oxygens from my 9 waters. So that adds up to 29. All right, well, I have 2 oxygens here now. And so 2 plus what is 29? I believe it's 27. So your question is, what times 2 is 27? I think that's 13.5. Mrs. Vanderwelde, what are you doing to me? Well, I gave you a double one, didn't I? So what do I have to multiply everything by again? I need to multiply everything by 2 again to get rid of this decimal. So this is 4, 27, 10, sorry, 20, and then 18. If you go back and check, yes, it all works out. Now, what kind of reaction is this going to be? Obviously, I have oxygen, I have carbon dioxide, I have water, I have a hydrocarbon with an oxygen. That's still allowable because it's still a hydrocarbon, and it's going to be combustion. And I think by now you've probably figured out that most combustions, if you have to do anything kind of weird, it'll be a combustion. So there's your clue for you. Most often, when you have to keep doing this doubling thing, it's a combustion. However, number 4 is another one that you have to, and it's not a combustion. So I'm going to erase some of this so I can have a little more room here. I want to also balance this one for you. So is there anything that shows up more than once? And your answer is, what is your answer? No. All right. So anything I should say at the end? Lead. Okay, let's save lead to the end. So how about hydrogens? I have 3 hydrogens. I have 2 hydrogens. I'll put a 3 here and a 2 here. How about phosphorus? How many phosphoruses do I have here? 2. How many do I have here? 3. So what number? I'm sorry, I'll try it again. How many phosphorus do I have here? Oh, I got it right. 2 and then 3. So I have to go ahead and I have to fix that. If I have 2 here and 3 phosphoruses here, I need to get 6 total, don't I? So I need to put a 6 here now. And I'm going to put a 2 here. But now what have I changed? I now have 18 hydrogens. So I need to use my eraser. See my little eraser here? And now I need to put the right number of hydrogens here. So if I have 18, I need to put a 9 here. Heaven forbid. And now what? How about my oxygens? What's 6 times 4? That's 24. 12 times 2, that works out. So my last thing is a 6 lead. So 6692. What kind of reaction is this? I have 4 things. If I have 4 things, then it's either single replacement, double replacement, or combustion. I see an element and an ionic compound, so it has to be a single replacement. Okay, number 5. I don't know if you saw how this would balance out. Mine has a typo. Yours does not. It should be Li. Should I save it at the end? The answer there was nitrogen. It shows up a lot. So let's save nitrogen at the end. So I have 3 lithiums. I put a 3 here. Let's do our, not our nitrogens, let's do our hydrogens next. So I had 4 here. I have 12 here. So I need to put a 3 here. I now have 9 oxygens. I now have 9 oxygens. Hopefully everything works out. So how many nitrogens do I have here? I have 1 and 3 and 3 more. So I should have 7 nitrogens. So I have 3 here and 3 here and 1 more. So that also makes 7. So my nitrogens work out. So what kind of reaction is this going to be? Well, I see 1, 2, 3, 4 things. So it has to be single replacement, double replacement, or combustion. And I see ionic and ionic. It is a double replacement. The next one I thought was very easily balanced, so I'm not going to spend time with that one. So I see 1, 2, 3, 4. It's going to be a synthesis, or excuse me, single replacement, double replacement, or combustion. I see ionic, ionic. It's a double replacement. Number 7 was pretty easily balanced, so I went ahead and it has 3 things. So it's a synthesis or a decomposition. 2 becomes 1. It's a synthesis. This one wasn't really hard. Just have some big numbers. Probably saved, I don't know, sulfur maybe? I don't know. So sulfurs I balanced actually first. Then my oxygens, then my sodiums. It works out. So what kind of reaction is this? I see a single element. I see an element. It's actually, sulfur is not diatomic. It's a big number, but all right. It's still an element and a compound. Element and a compound. So this is going to be, in a sense, a, single replacement. I started making the R too soon. Number 9. Now, you might say, this is a combustion. I see CO2. The answer is no, it's not. Look again. How many things do you have? I have 1, 2, 3. I have 3 things. It's either synthesis or decomposition. It broke down, so it's a decomposition. Now, number 10, what do you notice? Hydrocarbon, oxygen, carbon dioxide, water. I see 4 things, which has to be then, because of those oxygen, carbon dioxide, and water, it's going to be combustion. Hopefully this helped. I will actually put this on Schoology so you can listen to it again. I may put a couple other things on there. At this point, please, please, please use your time wisely. The sub will give you the review sheet now. If you have any questions, maybe talk to your neighbor, but it better be about chemistry. And be good to your sub. Thank you. Have a great day. Hope to see you tomorrow.